This is the third video for activity 4.2. If you recall, we're working with the height function that gave us the height of an object at any given time. And we were on top of the Sears Tower. We threw a ball up, it came down. This was the parabola that represents the position of the ball at any time. And in the last video, we found the axis of symmetry and the vertex, and we wrote down the practical meaning of the vertex. Right, it took 1.5 seconds for the ball to reach the maximum height. Now we're asked for the domain and range. The domain, notice if you look at the bottom of your page, you're asked the domain again. There's the domain and then the practical domain. So for now, we're just going to focus on the domain. The domain for any parabola is always going to be all real numbers. That means I can put in any value, any input will give me a valid output. Okay, so you can either type in all real numbers, or you can say x is somewhere between negative infinity and positive infinity. For this, I think I'm just going to write all real numbers. Right, again, any number is acceptable. Any real number is acceptable for my domain. X can be any value, or t could be negative a million, positive a million. Any value is acceptable. But for the range, we have to be careful. Okay, if I look at this parabola, the highest value on this line, right, if I were to trace this line, the highest or the greatest value would be this 1,486, right? That's the maximum output value we can have. All right, so the range would be any number lower than that maximum number, or that maximum output, which was 1,486. So we can write it, if I use the letter, I guess we can use y and t, right? So I think y has to be some number that's equal to or less than this 1,486. Next, we're asked to find the vertical intercept. So remember, the vertical intercept can be found by substituting in 0 for the input and solving for the output. We also know that the quadratic, when it's in this form, ax squared plus bx plus c, in this case they use the letter t for x, the c value is your vertical intercept, right? So 0, 1,450. Okay, so there's my vertical intercept, and again, the 1450, that was the c value in my equation up top. And the practical meaning, well, at time 0, the height of the object is 1,450 feet off the ground. Or you could say the initial height of the object is 1,450 feet. Okay, so again, the vertical intercept, just think about it, that's the point at which our graph crosses the vertical axis. So this is our vertical axis, so the vertical intercept would be the point where the curve crosses the vertical axis. And that point is 0, 1,450. The horizontal intercept is the point where the graph crosses the horizontal axis. So you can see this parabola, it happens twice. We cross the horizontal axis 2 times. So I wanted to go back to our previous document to look at different horizontal intercepts, right? You notice the case 1a, the parabola crosses the horizontal axis twice, once, twice. So parabola, it can have 2 intercepts or 2 horizontal intercepts, but look at case 1b. The parabola never crosses this x-axis. It never crosses the horizontal axis. So this would be a case where there's 0 intercepts, right? So here we have 2 intercepts. Here we have 0 intercepts. If you look at case 2a, we have exactly 1 horizontal intercept, right? The parabola only intercepts or intersects the x-axis or the horizontal axis 1 time. So when you're thinking about the parabola, how many horizontal intercepts can we have? The answer would be 0, as the case in case of 1b. We could have 1 intercept, as found in case 2a, or we could have 2 intercepts, as found in case 1a and 2b. So the question is, how do we find the horizontal intercepts? There are 2 ways to find the horizontal intercepts. The easiest way, I think, would be if we graph the actual parabola, right? Again, we had this negative 16t squared plus 48t plus 1,450. We want to see when that crosses y equals 0, right? If I were to draw a line at y equals 0, that is the horizontal axis. And then the intersection between my parabola and y equals 0 will give me my horizontal intercepts. So I press graph, and you'll see the red line is my y equals 0, the blue line is the parabola. And if I press second and the trace key, because above trace it says calc, number 5 for intersection, see it says first curve? Well, the parabola could be my first curve. I press enter. It says second curve. All right, that would be the y equals 0. And then it says guess. Well, there's two intersections, right? There's one here on the left and one on the right. So if I want to find the one on the right first, I'm going to move my cursor toward the right. And I'm telling my calculator, I guess there's one over here to the right. And then I actually have to press enter. And it's saying, okay, at 11.137, let's just call it 11.1, we have a horizontal intercept. So we found one. So let's enter that. Okay, so for horizontal intercepts, this is the first one. But if we look at our graph, there's a second intersect, right? It happens on the left side of our parabola. So I have to press second and trace again. Number 5 for intersection. And this time it says first curve, I press enter. Second curve, I press enter. And now when it says guess, well, we already know this intersection on the right. So I'm going to move my cursor all the way to the other side, right? The intersection that I do not have. Takes a moment, bear with me. And then I'm going to press enter. And this one's at negative 8.13. Okay, let's just call it negative 8.1, comma 0. And now when it says practical meaning, well, the negative has no practical meaning. No prac. Right, because remember, the input represents the time. So there's no such thing as negative time, right? We don't really care about the position of the object at negative 8.1 seconds. But at 11.1 seconds, the height of the ball is 0, right? If the input represents time and the output represents height, at about 11.1 seconds, the height of the object is on the ground, or is 0. So I think this answer should do it. After 11.1 seconds, the height of the ball is 0, or the ball is on the ground. The second horizontal intercept has no meaning because we don't have or deal in negative time. All right, and again, just looking at our graph, these are the two horizontal intercepts. All right, so up here, we're on the roof. We throw the ball up, it goes up, and then eventually the ball comes down until it hits the ground. And these numbers on the horizontal axis tell you the time. And the y-axis or the vertical axis tell you the height, right? So at any time, I can determine the height. Okay, I think we'll stop there, and we'll do one more video to finish up this activity 4.2.